Yeah.
key part here.
Oh, that thing, yeah.
Oh! Okay. Now watch, he's gonna wait right past me.
Okay, I got him. No. This still doesn't sound right.
It's still like turning off from the page.
Yes. Yeah, I did that. I got 148 degrees.
Closer to 149.
Yeah, it's closer to 1.
Oh, I wasn't looking at the multiple choice.
So this is not very complicated.
It's hot coffee.
Very hot coffee. It'd probably be melting the cup. But that's okay. Yeah, why is the coffee that hot?
I don't know. 49 not bad.
No, I
Or
guess
anything boiling is 212. 149 is not horrible.
It's still hot. So I would put that as me. I'm gonna get everyone's coffee.
I'm not a fan of coffee at all.
How do you function?
how I function.
You
I know
baby
that.
function.
Alright, for this one, this is average value. Right? So average value, we're just taking the integral of the function and multiplying that by 1 over b minus a. So in this case, 1/10 times the integral from 0 to 10 of our function. I think we plug that in the calculator, we get about 149 degrees.
Yeah, if you round up.
That's what they ask you to do. The nearest degree. You okay with that one? Well, this was a calculator question, so that means you would have about 3 minutes to do it. So we've got some processing time there built in. There are 15 calculator multiple choice questions, and you have 45 minutes for that section. All right. How about the homework? Not good.
There was one problem for each question that I could not do.
It was really good for me.
The only thing that I don't know how to do is to how to find like where like velocities increasing and finding like min and max and we just have an equation and not that. Because I don't think I can make like the charts, like the sign chart.
I did a sign chart for 4, and I did for 6. Okay, I have a question.
For 6.
Okay. Is that where we want to start? 6A?
Can you start at 2C?
2C? Sure.
Like,
2B?
I figured out that's where the acceleration is positive, but like I just don't know how to find it.
It's just
I said nowhere and or where t is equal to negative.
Okay, you don't have to do that one.
Wait, which one?
No, I'm cool with doing 2C.
So 2C is where we're starting.
I thought we were talking.
Oh, I need to do B, but
Okay, B. Find when the instantaneous velocity is equal to the average velocity. Okay, so in part A, you needed to find the average velocity. So what did we find the average velocity to be? We need that for part B.
yeah, that's where I did.
Okay. So
I got negative 4. It shouldn't be negative.
So if we are given acceleration, okay, we know acceleration is negative 4. This is average value, right? This is exactly what we did in the warm-up. So if I want to find average velocity, first I need my velocity function.
I know it's like S with E minus S with
So yeah, there's two ways that we can look at this. If we're given a position function, that's how we would look at it. Yeah. But here, all we're given is an acceleration function and then an initial value for velocity. So here, what we can say is, well, if my acceleration is negative 4, then my velocity, my v of t, will be the integral of acceleration, or the antiderivative. So negative 4 dt. So the antiderivative of negative 4 is just negative 4t, right? Plus c. Since we don't have bounds, we would need a plus c. But then they tell us what our c will be. Okay, my v 0 is 12. So what this tells me is that my velocity function is negative 4t plus 12.
Equal that into.
So then, if I want to find the average velocity, okay, if I have my velocity function and I want to find the average velocity, that's where I'm doing average value. So if I want over this interval from 0 to 8, I would do the integral from 0 to 8 of negative 4t plus 12 dt. And we get negative 4 for that. Yes, so we need that number to do part B.
Yeah, I was like, what?
So yeah, so now for part B, we want to find when the instantaneous velocity equals the average velocity. So the average velocity is negative 4. So I want to say, well, this function, negative 4t plus 12, is my instantaneous velocity. I want to see when the instantaneous velocity equals negative 4. So I'm just going to say negative 4t plus 12 equals negative 4. And this is pretty simple to solve then. Right? We get negative 4t equals negative 16, so t equals 4. So at 4 seconds is where the average velocity equals the instantaneous velocity.
Why was that so much easier?
Well, because I know what a point is. So then, part C, find when the velocity is increasing. How do we do that?
It's the slope of one. It's a trick question. It's the slope of velocity, so it's just acceleration, right? When that acceleration is positive.
Right.
Which it never is.
Right. So I guess it kind of is a
I
trick
was
question.
right.
Acceleration is just negative 4, right? Negative 4 will never be a positive number, because it's always negative 4. So velocity is never increasing. Right. And then D, are we good with D? Total distance? I mean, this is just setting up the integral, right? So total distance is the integral of the absolute value of velocity. So absolute value is negative 4t, or absolute value of negative 4t plus 12 dt. So we would just plug that into the calculator.
Even though it says no calculator.
Yes, we are going to assume that whenever we're doing total distance, we can use the calculator. Because we don't have time to talk about how to do it without a calculator.
For
4b. Alright, so particle moves along the x-axis. Again, on this one, we are given an acceleration function. And we are given, let's see, we're given an initial velocity and an initial position. So, find v of t, and then for what values of t is the particle moving to the right. So, to find v of t, we would take the antiderivative of acceleration. Right? So, antiderivative of acceleration. Well, this is for A, but we will need this to do B. So, antiderivative of 6t plus 6 is, right, I mean, our initial velocity is negative 9, so I can just tack on that negative, well, actually, I'll write it as plus c, and then we know that our initial value is negative 9 for velocity. Okay, so this is my velocity function. Now, part B, for what values of t is the particle moving to the right? The particle is moving to the right whenever velocity is positive. Right? So, we would just want to make a sign chart. So I need to take my velocity function, set it equal to 0 to find my critical values. Put those on a number line, make a sign chart. So, I can just divide out a 3 here, and just make this t squared plus 3t plus 2t minus 3. then I think this factors nicely right, into t plus 3 and t minus 1. So we would get t equals negative 3 and t equals 1. But there's only one of those that are usable, right? Because we're talking about times that are greater than or equal to 0. So the only actual number we get is 1. So if I put that value on my sign chart, take a value less than 1, and plug it into velocity. Right? So if I plug 0 in here, I have 3 times negative 1. That's negative. If I take a number greater than 1, say 2, 5 times 1 is positive. So velocity is positive from 1 on. And I don't think we have, no, we don't have an upper bound. So we would just say the particle is moving to the right from t equals 1 to infinity. You okay with that one? What else? Are we done with 4?
All right. 6A.
What I did is graph it and found like the minimum point on the graph, but I don't know if that's the right thing to do. Because it was like a it's really slow changes from positive to negative. Sorry. I just graphed it on the method and found the new point. So it was like a
You graphed the velocity function?
yeah, and then like found the point where like there was a horizontal change.
So that would give you the minimum velocity, right? So easiest way might be to take the derivative. So here, we could use a product rule, or it might be easier to just multiply it out, right, and then take the derivative. So we multiply it out, what will we get? T squared minus 4 minus 3, so minus 12t plus 9. Minus t minus 3, so it would be minus 4t times 3. Right? Well, so here, I can do it in steps. So if we just multiply the t minus 1 and the t minus 3, we'd have t squared minus t minus 3t, so minus 4t plus 3. And then if we distribute the 3 through 3t squared minus 12t plus 9. So then acceleration would be the derivative. So 6t minus 12.
And then you graph this,
Sure. You can graph this.
or we can just see where it equals 0 for that divided by 2. Right?
Well, but we will also have to check the endpoints.
Yeah.
So it might be quicker just to graph it. So I mean, this is just a straight line, right? So if I'm graphing this linear function and just looking at the interval 0 to 5, where will my minimum occur? I'm going to guess it occurs at t equals 0. Since this is a positive linear function, it's going to keep increasing. So the smallest value will occur at the beginning at t equals 0. Are you okay with that one?
It is. Yeah. Okay.
So I just have to put in velocity.
The instantaneous velocity equals the average velocity.
Yeah, so I just need the velocity function.
So to get average velocity, that's the 1 over v minus a times the integral from a to b. Yes.
And then set that equal to
To the instantaneous velocity, yeah,
okay.
which we have.
Okay.
Any other questions on this? Making a little more sense? All right, today then, let's take a look at a couple of AP problems. Ones that have been on the last two tests, 2018 and the 2017 tests. All right, let's take a look at the 2018 problem first. Thank you, sir. It's this one. This one's the 2018. Okay, this question was on last year's test. And I actually don't think this one is that bad. I think this was one of the easier problems on the test. This was on the calculator portion. Okay, so we can use a calculator on this. So all it says is a particle moves along the x-axis with velocity given by this function between 0 and 3.5 seconds. And then we are given an initial position. The particle is at position x equals -5 at t equals 0. So part A just says find the acceleration of the particle at t equals 3. How would we do that? All right, find the derivative of the velocity function. Now, since this is a calculator question, you don't have to do that by hand. Right? We talked about a way to just plug in a derivative into the calculator. Do we remember how to do that?
How 6?
So we can either do Calc 6 or Math 8. If we're just trying to find a single value, it might be easier to just do Math 8 from the home screen.
Yeah. So do I have to write this down, like show work?
Yeah, so to show work for this, I think it would be enough to say a of 3 equals b prime of 3 equals whatever value we get. Okay, because we're not actually finding what the derivative is. Okay, we're just finding one specific value. So to show work, and I mean you would need to write something out, but I think this would be enough to show work for this
Okay.
for part A.
So this would be
So what is it? -2.
-2.118.
Is that what everybody else got? All right, now We're actually not even given units, so we don't have to worry about units for this problem. Alright. What about part B? Find the position at t equals 3. You have to take the antiderivative. So here, our work would just be setting up the integral. Okay, so what will my bounds be?
0 to 3. No, because it wants it at 3.
We want the position at 3, not at 3.5. So that's one place where they get tricky, right? Up here in the problem, it says we're talking about the interval 0 to 3.5, but the question just says find the position at 3. Right? So I would need to take the antiderivative here. So 10 sine of 4t squared. Plus 3. Don't forget your dt. Shall be smited. Math 9. Yes. So what do we get here?
No. What did
We
you
got
say
two
no?
different things.
Because I typed it all in, and then when I went to hit the over button, I hit clear. And
3.239. Or yeah, I guess if we truncate.
Oh, for 10 on, I just made that try.
So is that my final answer?
You have to do the lines.
So is that my final answer for B?
Yes.
No.
What?
This number.
Oh, position at -5.
Right. This number is how far the particle moved from 0 to 3 seconds. We have not taken into account yet our initial position. We are told that the particle started at x equals -5. So we started at -5. We moved 3.239 to the right. Where are we now?
We have to subtract
negative
1.7.
So final position,
Oh.
Close enough.
which is, we can say S of 3 is equal to -5 plus 3.239.
Negative 1.76.
Well, since we make this, we round this instead of truncate. You need to be careful. So if you wrote 3.239 there, and then said this was -1.760, that would actually be wrong. Right? So you need to make sure that you're consistently truncating or you're consistently rounding. Don't mix and mingle truncating and rounding. You good with what truncating is?
That's 3, cut it off.
Right. Truncating is going to 3 decimal places and just chopping off the rest. Rounding is looking at the 4th decimal place to determine what the 3rd decimal place should be. And the AP accepts either way. Just make sure that you are consistently doing one thing or the other and not mixing truncating with rounding.
Like, if you want a problem.
Right. Yeah. So, we okay with B? Right, not too bad, right?
This isn't too horrible.
Yeah. So then C
Until we get
says
to
evaluate
C.
2 different integrals, the integral from 0 to 3.5 of v of t dt, and the integral from 0 to 3.5 of the absolute value of v of t dt, and explain what each of these things mean. So again, we can just plug these into the calculator. So we do the integral from 0 to 3.5 of v of t dt. What do we get?
2.8.
2.844? Is
And that's
that what everybody else got? Ruby was just ahead of the game.
No, I just went up, and since I already had the thing in, I just changed the 3 to
So I mean, double check that you get that when you plug it in. Make sure that you're comfortable plugging all this stuff in here. No. Bless you. So what? A short explanation of what is happening here. We're taking some function, right, and finding area under a curve. So there could be positive and negative area under that curve. So that's the number that we got here. If we take the absolute value of this function, what we're doing is taking this negative area and flipping it up. So we will more than likely get a completely different value when we take the absolute value of a function. So or take the integral of the absolute value of a function.
all that different.
So what do we get for that?
Absolute value,
3.737.
3.737.
So now we need to explain what each of these things mean. So what is the first one?
No, because that's
It's the area under the curve.
Right. That's the one. Displacement. Okay, if we are taking the integral of a velocity function, we will get the net change in position, or we call that displacement. Okay, so for this, we would say this is the displacement of the particle or the interval. What's up?
Is for the absolute value, that's
3.737. That's what Ruby told me. That's what the calculator told Ruby. Alright. So what about the second one? If I take the integral of the absolute value of velocity. Total distance. Distance of particle. This interval.
Is it okay if I say on this interval?
That's fine. So then the last part says we've got some other particle moving along the x-axis, and this time we are given a position function. Okay, we're told its position is given by t squared minus t over the same interval, 0 to 3.5. At what time are the two particles moving with the same velocity?
Okay, so we have to take the velocity, so we need to take the derivative.
Right? So we need the velocity of this particle. So we need the derivative of this position. So t minus 1. So we can say, well, you tell me, what do we need to do now?
Set them equal to each other, but I really don't want to do that.
You're right. So we need to find where they're equal. So I'm going to say 2t minus 1 equals this. Right? But remember, this is a calculator question. So I do not need to solve this by hand. What's the best way to solve something like this using the calculator?
Graph.
Graph it. Right? So I would graph each of these in a separate y equals. So I can say y1 equals 2t minus 1, y2 equals this. And what am I looking for on the graph then?
Intersect.
Where they intersect. Exactly.
We need to do. Oh, it looks like
value is 1.57.
Is there just one? Okay. Is that what everybody else got? Just one point of intersection?
Unless there's one right there, and I just can't.
Do we feel comfortable with finding something like that on the calculator? So, I mean, that was it. We just got 9 points on this free response. Right,
That wasn't horrible.
right. That one wasn't that bad.
Especially if I have the calculator.
This one was a calculator question.
I stupidly would have done it wrong.
Why?
I just accept
Questions on this one?
That's stupid.
I probably will
All right,
do that on the
Then on the back, there is a question from the 2017 test. Okay, also dealing with particle motion. This one was a non-calculator question. Okay, this one was on the non-calculator part of the test. So we've got like 12 minutes left here. Why don't you guys try this one? I'll come around and help push you in the right direction. See what we can do on our own with this one here. I mean, you can work with each other. You don't have to be silent, okay? But try this one without me guiding you with the board.
Oh, just leave my calculator there because I don't need it. Well, I need it, but I can't have it.